Hello students, welcome to Eshwari Thaniksha channel. Students, in this video we are going to learn very important concept, that is how to find the magnetic nature of all this species and also how to find their bond order and their bond length. So this is one of the very important question. If you see previous year question paper, so you can see such type of questions will be given where their bond order will be asked or their bond length will be asked or their magnetic nature will be asked. So in this video we are going to discuss. So simple trick I'll teach you. Using that you can solve this question. Students, before going into the video, please subscribe the channel and also share this video with your friends. So now let us start. So students, nitrogen atom has how many electrons? So nitrogen atom has totally 7 electrons. N2 will be having 7 plus 7, which is equal to 14 electrons will be present. So if a system has 14 electrons, that is up to 14 electrons, the molecular orbitals we can write like this. So that is sigma 1s, then sigma star 1s, sigma 2s, sigma star 2s, then pi 2px equivalent to pi 2py, then sigma 2pz, then pi star 2px equivalent to pi star 2py, and then last sigma star 2pz. So this is the order of molecular orbitals we will be writing, that is increasing order of their energy level. So students, as you know that, so if a star is present here, we call that as anti-bonding molecular orbital, and this will be bonding molecular orbital. So you know that there are two types of molecular orbital. One is called as bonding molecular orbital. Second type is called as anti-bonding molecular orbital. So if a star is present, so here this one and this one, and here this one and this one. So all these are anti-bonding molecular orbitals. So now we are going to fill the electrons in this. So let us fill the electrons. So first let us take for nitrogen, N2. So students, in N2 how many electrons will be present? In N2 totally 14 electrons will be present. So fill here 1s2, 2 electrons here and then 2 electrons here. 2 plus 2, 4, 6, 8, 10, 12, 14. So totally we have filled 14 electrons. So now we are going to see whether it is diamagnetic or paramagnetic in nature. So if all the electrons are paired, it is diamagnetic in nature. So here you can write it is diamagnetic in nature. Diamagnetic. Why? Because all the electrons are paired. So next we are going to find the bond order. So students, to find the bond order, we have the formula here. So you can see bond order is equal to half of NB minus NA. What is this NB? NB is nothing but number of electrons in the bonding molecular orbital. Na is number of electrons in the anti-bonding molecular orbital. So now let us calculate the bond order for N2. So bond order will be equal to half. How many electrons are present in the bonding molecular orbital? Let us see. So here you can see 2, 4, 6, 8, and then here you can see it is 10. So totally there are 10 electrons in the bonding molecular orbital. So I'll write here 10 minus. How many electrons are present in anti-bonding molecular orbital? 2, 4. So there are only 4 electrons. So I'll write here 4. So this is equal to 10 minus 4 is 6 divided by 2 which is equal to 3. So you got the bond order as 3 for N2. So next we will calculate for N2 plus. So students, in N2 plus, how many electrons will be there? So N2 plus meaning is we are going to remove 1 electron from 14. So if you remove 1 electron from 14, it becomes 13 electron. So here it will be 13 electron. So now fill the electrons. So when you fill the electrons, so 2, 4, 6, 8, 10, 12, 14. So this one we will erase it, and then here we will write it as 1. So 1 electron, it becomes 13. So now students, whether it is diamagnetic or paramagnetic in nature, if unpaired electron is present, it is paramagnetic in nature. So therefore we can write N2 plus as paramagnetic. So paramagnetic in nature. Next we are going to calculate the bond order. So which is equal to half of how many electrons are present in bonding molecular orbital. So just count 2, 4, 6, 8. So totally 8, and here 1 plus 1, 9. So totally there are 9 electrons. 9 minus how many electrons are present in the anti-bonding molecular orbital? Count 2, 4. So totally 4 electrons. So 4. So this is equal to 9 minus 4 is 5. 5 divided by 2. So which is equal to 2.5. So you are getting 2.5 as the bond order. Next is N2 minus. So N2 minus, how many electrons will be there? N2. So here you can see N2 meaning is 14 electron. N2 minus meaning is you have to add 1 electron to 14. So 14 plus 1 will be equal to 15 electrons. So here I'll write it is equal to 15 electrons. So now fill the electrons. So 2, 4, 6, 8, 10, 12, 13. So totally we have written here 13. I'll rub this. So here I'll write 2. So it becomes 14, and here I'll write 1. So totally it becomes 15 electrons. So students, find out whether it is diamagnetic or paramagnetic in nature. So there is unpaired electron. Therefore it is paramagnetic in nature. I'll write it as para. Para meaning is paramagnetic in nature. Let us calculate the bond order. So bond order is equal to half of, count the number of electrons in the bonding molecular orbital. 2, 4, 6, 8, 10. So you can see here totally 10 electrons. So 10 minus anti-bonding molecular orbital, how many electrons are there? 2, 4, and then 5. So totally there are 5 electrons. So you can write here 5. This is equal to 5 divided by 2, which is equal to 2.5. So next we will go for N2 2 minus. So how many electrons will be there in N2 2 minus? So you know that nitrogen has 14 electron. So 2 minus meaning is you have to add 2 electrons to this. So 14 plus 2, it will be equal to 16 electrons. So I'll write here 16 electrons. So now let us fill the electrons. 2, 4, 6. So 2, 4, 6, 8, 10, 12, 14. So 15 are there. So one more we have to fill. So here we have to write the electron. So it becomes 16 electron. So now find out whether it is diamagnetic or paramagnetic in nature. Since unpaired electrons are present, they are paramagnetic in nature. So we can write this as paramagnetic. So let us calculate the bond order. So bond order is equal to half of how many bonding electrons are present in bonding molecular orbital. Count 2, 4, 6, 8, 10. So totally there are 10 electrons minus anti-bonding molecular orbital, how many electrons? 2, 4, 5, and then 6. So it is 6. So this is equal to 10 minus 6, you will be getting 4 divided by 2, which is equal to 2. So we got the bond order for all the species. That is, we got N2 bond order as 3, N2 plus as 2.5, N2 minus as 2.5, N2 2 minus as 2. So now we'll write the bond order. So bond order for nitrogen, it is greater compared to N2 plus, and this is equal to N2 2 minus, because bond order is similar for both 2.5 and 2.5, which is greater than N2 2 minus. So this is the bond order. So now how to write the bond length? Bond length is equal to, so students, remember this trick. Bond order is inversely proportional to bond length. Meaning is, when bond order increases, bond length will decrease. So now this order will become reverse. N2 lesser than, then N2 plus, N2 minus, and then N2 2 minus. So now a small change is there here. So here it was equal. So you can see here the bond order of these two are equal, but here the bond length is not equal. So it is not equal, but you can see N2 minus, the bond length is greater when compared to N2 plus. So what is the reason for this? The reason for this is, you can see in N2 minus, the number of electrons in the anti-bonding molecular orbital is more. Therefore, stability will become less. Here you can see N2 minus, anti-bonding electrons are 5. Whereas N2 plus, number of electrons in anti-bonding molecular orbital are 4. So here 4 and here 5. So here it is more. So here if it is more, then stability will be less. So stability will be less. If stability is less, then bond length will increase. Therefore, in N2 minus, the bond length is increasing. So is that clear? This is the order of bond length and this is bond order. So I hope it is clear to you. So you can take a screenshot of this and then go through it once again. So students, if you like the video, you can share with your friends and also subscribe the channel. I'll meet you in the next video, students. All the very best.